Once you have opened the MFCTool software on your computer, you have the possibility to select the instrument that you will be working with. In this case, we are selecting the PT2026-05 connected via the USB port. You would also have the choice of connecting a PT2026 on Ethernet port if you've done that connection, or using serial port you can connect to legacy MFC3045 instruments. Once you're connected, you have access to additional information regarding the instrument that you're using, main unit, the model, serial number, and so forth. You also have access to the last calibration date of the main unit and of the probe array. At Metrolab, we recommend that you calibrate and normalize those two instruments every year. You can also see at the bottom of the screen the value of the minimum and the maximum range that you can use, here expressed in megahertz from 60.66 up to 67.05 megahertz, which is characteristic for 1.5 Tesla probe array. If you need any additional information, you can reach out to the help menu by clicking on the question mark at the bottom left of your screen. It will take you to a simplified version of the MFCTool manual. It will show you a very simple interface with additional information regarding the different values presented on the screen. Once you are connected to your magnetic field camera, the important step to do is to go to the Search tab and measure the field of the magnet that you're interested in mapping. You go with Start, and you're measuring the magnet from the minimum to the maximum value and defining what is the average value of the field of the magnet. This process here is much faster than what will happen when you do it on your instrument, as we are in the emulated version of the MFCTool. You will save this value as a preset value to speed up the acquisition process during the mapping of your magnet. If you need any additional information, you can reach out to the help menu by clicking on the question mark at the bottom left of your screen. It will take you to a simplified version of the MFCTool manual. It will show you a very simple interface with additional information regarding the different values presented on the screen. Once you have saved the preset measurement range, you can access the Mapping tab of the MFCTool software. This is where you can select the number of positions you will measure during the full rotation of the probe array. Here, 12 positions per turn for an increment of 30 degrees. You can also decide to repeat the measurement of the first angle as a sanity check or to correct for drift. You are now ready to collect 13 sets of measurements. Using the preset measurement range acquired earlier, you will speed up the acquisition of the field value of each of the probes. Here, the search range is plus or minus 100 ppm around the central value measured earlier. You can always revert to the full range of the probe array with a range of 50,000 ppm or 5% around the nominal value of the probe array. Here, 63.86 MHz or 1.5 Tesla, as can be calculated using the gyromagnetic ratio of 42.57 MHz per Tesla. Averaging is set to 5 in the case of the MFC 2046. This averaging of 5 is sufficient to achieve a high accuracy with the post-NMR technology, unlike with the legacy MFC3045 where you would need an averaging of 60. You can also add comments to your measurement file at this point. You are now ready to map your magnet. Place the probe array in position 1, angle 0 degree. Press Start and you acquire the field value for all 25 probes of this probe array. In real life, it takes around 5 seconds for the complete acquisition. The software takes you to the position 2, but you need to physically rotate the probe array to position 2, 30 degrees. You are now ready to acquire position 2. Again, the software takes you to position 3 automatically, and once you have physically moved the probe array to position 3, click Start. This way, you will acquire all 13 positions of the probe array. If for any reason you need to repeat an angle, highlight that line and press Start. Data visualization. You have now completed the acquisition of your map. You can visualize individual probes around the full acquisition circle by flying the mouse pointer over the probe of interest. Probe 2, probe 7 for example. You can also highlight some of the probes. Select None, and then select probe 7, 12 and 25 for example. Go back to the previous view by selecting All. You have the possibility to zoom in areas of interest and zoom out. The 3D map presents the field values measured for all data points as a function of the probe position and the angular position. Zoom in and out using the wheel of your mouse and click on a point to see the specific data. The table view allows you to see the data of all data points, angular position after angular position. The probe number, the time of acquisition, average frequency and standard deviation for all 5 measurements. Remember we had selected an averaging of 5. And also you can see if all 5 data points were acquired successfully. The Statistics tab offers the statistical information for each of the angular position, angle of acquisition, mean, minimum and maximum frequencies, and standard deviation. The Information tab summarizes the information acquired during this mapping. And also, don't forget to save your experiment. Other modes are also available. The positioning mode is useful for a magnet development team. It will allow you to measure all probes of the probe array and center the probe array in the magnet based on consecutive measurements. The drift mode will allow you to track your magnet drift over longer periods of time. Ramping is also a continuous measurement where you can follow either a single probe or all the probes of the probe array. This is only a tracking measurement. It is not used for regulation directly out of the MFCTool. You also have access on this software to the main setting tab, where you can decide whether you want to be looking at the field in megahertz or in Tesla. In this presentation, we have selected megahertz. We could have done it in Tesla. Same for the plotting. You can also define where you want to save the data acquired during the measurements. You can decide if you want to automatically check for an update of the software on Metrolab website, and you have access to our contact information in case you need it. To return to the instrument selection, click the icon at the bottom left of the screen.